So now we are actually moving into the factor tables and engineering economics. And so there's a few more definitions that we're going to get to. And here this is a compound amount factor. And we're going to use, this is called the factor table shorthand. Okay, this is a shorthand. And the purpose behind this is we can, and you'll see this very, very shortly, whether or not we can use the actual equation or the factor tables. They calculate it all out for you, so it's easy. It's a time saver for you during the exam. And so let's continue this. So this is called a factor table shorthand. The way that you address this, that's the actual equation for it. All right, 1 plus I to the nth power would give you the compound amount factor. Now, the factor tables are presented to you there. And what we're going to do is take a look at some of the concepts here, such as, and we're going to define these. So I'm kind of moving you to an introduction of what these are, okay? But we're gonna expand on these. This is gonna be, you're gonna hear this a dozen times before we finish this session. So what is present worth? And remember, in the cash flow diagram, we are doing our analysis on day 0. Okay, it's day 0. That's our present worth. There's this concept known as discounting. It's the inverse of compounding, and it's determined the present amount which all specific future sums are produced. An annual amount, although the actual definition of A in engineering economics is the annual amount. It's the end of periods. It's not actually calling out as an annual. It could have monthly or daily, but we revert to the N, and you'll see that shortly. Okay, so I'm just introducing these concepts, and we'll apply all of these. We're looking at it from an abstract point of view. We're going to make it a visual representation. We'll be able to see and work with these concepts. And the last one here is a gradient amount. What is a gradient amount? There's a uniform gradient. Okay, in looking at a table, okay, we can plot dollars and we can plot profitability, and so we have a gradient, just the same as in our coordinate system. We have a grade and a gradient, and it's either an increasing or decreasing gradient, where the y and the x variables that you have, either time and or dollars, you'll have time and dollars, it increases or decreases over time, and that's a gradient, but it's uniform. Okay, it has to be uniform, and we'll see that shortly. All of these will be detailed and explained in detail. A few more concepts. Let's take a look at capitalized costs. We're going to apply this equation, and to bring it to your attention, capitalized cost is equivalent to present worth. A capitalized cost is equal to present worth. When you're in business, you want to know, what is our cost today in our cash flow diagram? 0. And we need to know what our costs are so we can find the investment strategies for it and or the finance strategies for it. So capitalized cost is equal to present worth is equal to life cycle cost, and that'll be expanded on. And an annuity is defined here. An annuity is just an interval of time. It's all it is. It's an interval of time. So annuity is a series of payments made in equal intervals. Overwhelmingly oversimplified definition for it, and that you can use. And the last one here, we're going to get more and more into the benefit cost analysis. Our benefits are the numerator, our costs are the denominator. To oversimplify what a benefit cost analysis is, let's say we make something and we're going to sell it for $1. That's our benefit. What did it cost us? Well, let's say it cost us $1. Well, what's our benefit cost analysis? All right, it's 1.